The topic of this video is solving inequalities with variables on both sides. What you want to remember about this process is that solving an inequality is always just like solving an equation. So anything you would do in an equation, you'll also do in an inequality. So if example 1 was an equation, the first thing we would do would be on both sides to distribute and combine like terms. So when I do that, I'm going to get 2x minus 16 plus 9 is greater than or equal to 3 times 4 is 12 minus 3 times negative x is 3x minus 4. Next, I'll combine like terms, which on the left side means the negative 16 and the positive 9. So 2x and then negative 16 plus 9 gives me negative 7. And we still have less than or equal to. And then on the right side, our like terms are the 12 and the negative 4, which is going to give me negative 3x plus 8. Because as far as like terms go, you want to remember that the sign in front sticks to the number. So that's why this was negative 16 and positive 9, which made negative 7, positive 12, and negative 4, which made positive 8. And I remembered to keep this negative sign with the negative 3x. Now that we've distributed and combined like terms, our next job is to move all the variables to one side of the inequality. I move them to the left, and to move all the numbers to the right side of the inequality. So if I'm moving all my variables to the left side, that means that the first thing I need to do is add 3x on both sides, which gives me 5x minus 7 is greater than or equal to 8 after the 3x's cancel out. Next, I need to add 7 to both sides, which is going to give me 5x is greater than or equal to 15. Now I need to divide to isolate my variable. And the one thing you want to remember here is that you might need to flip the sign in this step, which is different from solving an equation. So here I'm just dividing both sides by 5, so I don't need to flip the sign. And that's going to give me x is greater than or equal to 3, which I had to write over here on the right because I was running out of room. So now that we have our answer, x is greater than or equal to 3, we still need to graph the solution. So that means that we need to draw a closed circle at 3 because it's greater than or equal to. And then, since it's greater than, we're going to shade all the way to the right side to say that this can keep going on forever and ever and ever. So we're shading from the closed-in circle to the right, and we're done. This is the basic idea behind solving an inequality with variables on both sides. What we're going to look at now are two special cases. So again, we're going to solve each inequality and graph the solution. So in number 2, the first thing I do would be to distribute, which gives me 2x plus 6 is less than 5 plus 2x. Then I want to move all of my variables to the left, so I'm going to subtract 2x on both sides. And when I do that, my 2x's actually cancel out on both sides, leaving me with 6 is less than 5. Now, the funny thing about 6 is less than 5 is that that's false. And that inequality is always going to be false because since the variables cancel out, they don't matter. Regardless of what x I put in, I'm always going to end up with something that's false because 6 is less than 5 doesn't work. So just like we would when we get a false equation, when we get a false inequality, we say that the solution is no solution. So when you get a false inequality, we say the answer is no solution. And now the thing I'd like you to think about is, what does the graph of no solution look like? I'm going to leave that to you to put the number line in your notebook and then say what you think you would write for the graph of no solution. Next, we'll look at number 3. So again, in this one, we need to put all the variables on the left and all the numbers on the right since there's no distributing or like terms. So that means I subtract x on both sides. And just like in number 2, when I subtract x on both sides, the x's are going to cancel out, leaving me with just 5 is greater than or equal to 3. But the difference is that this inequality is true. So it doesn't matter what x you put in, you're always going to get an inequality where the left side is greater than or equal to the right side. So just like we would have said for an equation that's true when the variables cancel out, an inequality that's true when the variables cancel out is going to have a solution of all real numbers. When something's circled in rainbow pen, it must be important. False inequalities, no solution. True inequalities, all real numbers. Now again, I'm not going to tell you what all real numbers looks like graphed on the number line. I'm going to leave that up to you. So for the graph, draw your number line and say what you think all real numbers would look like as a graph, and we'll talk about it in our next class. And we're done. You know what you need to know about solving inequalities with variables on both sides.